So for the last few years, I've worked for John, and he's helped sort of incubate this project in ARM. So I'm very grateful to him, but also he is my boss. So if we're doing a good job, go and have a chat later in the bar. Okay, so I wanted to talk about the mission. So I'm going to talk fairly high level here, and later we're going to dive into some details. But yeah, I want to start with, we're assuming we have the technology. We've reached a really interesting inflection point where process technology, the performance you can get into, microcontroller hardware, power consumption, cloud services, all these things, they're all coming together. We're sort of in this position where I'm taking this point where we have the technology. It'll obviously advance, but we're in a very interesting state now. And this is the opportunity we're seeing. So obviously ARM and partnership almost helped define this mobile industry which connected everyone in the world. So that was unforeseen. But the next opportunity is actually pushing that intelligence into all the sort of things that are around us. But yeah, not to dwell on this. This is something that I guess we took very seriously. So when we were starting the Cortex-M project and defining the architecture, which is actually when I met Chris and we started thinking about the sort of problems that might come when we were driving this new microcontroller roadmap. I wanted to show you some of the things that were actually the first things we wrote down about our ideas. So this is I've got a few slides from our first ever internal presentation from mbed, which I'm sort of quite proud of, because I think if you have a good strategy, you have tactics change all the time, but if you have a good strategy, then that's a really good basis to drive the technology. So this is one of the first slides I ever wrote on this concept. I'm basically saying, microcontrollers are a solution looking for problems, and we don't really know what they are. And you can have someone who's incredibly well trained trying to think up these ideas of how they're used, but really it's the guy in a different domain who sees the opportunity, sees the need to go and develop this stuff. And there's a really nice quote from William Platt Yeats about filling a pail or lighting a fire. And this is not about someone being clever versus being stupid. It's about them having great insight into their business, understanding what changes in their business would have significant impact, where risk is, where the reward is, and things like that. And we assumed that if you were this guy, the other thing you would do is you wouldn't tolerate the sort of timescales that the guys who invented this industry kind of had come to accept. And we always had this idea of a plumber. You ask the plumber how much it's going to weigh. Oh, that's going to be a hard problem. And I think what we realised is that this new set of developers, they just wouldn't tolerate what had become expected of how complex or how time-consuming something would be to understand the risk of taking on a project or to mitigate the risks of taking on a project. And to grow an industry, you need to get investment. And the way you need to get investment is to get the risk-reward calculations right. So anything you can do that reduces risk allows an industry to scale. That's how investment comes to be. And our original premise was, so 3D printers were just starting to come onto the scene. People started using frameworks like Ruby on Rails to develop websites, and it had a huge change in productivity. And this is where we set off on our initial project to say, well, we want to actually do rapid prototyping for the intelligence that you embed into things. That's the sort of barrier. And the approach we were going to take, I based off something that I quite admire. This is the original ARM business plan. I don't know if it's public domain, but I think it should be. At least one slide of it is now. But this was the opportunity that ARM were looking at when they first set out this business plan. So obviously this was before I joined ARM. But the main observation was we can take a technology that is going to push something forward. It's going to push performance forwards. But we're not going to go on that path that everyone's going on. We're actually going to make a slightly different trade-off. And we're going to drive the price down and still gain some performance, but not all of it, and open up effectively what is a disruptive market. So I thought this was quite good. So this was my original business plan slide, which was basically saying, well, we've got all these 8-bit micros, we're designing Cortex-M, we can see that we can get the price point, it might be 5 years away, it might be 10 years away, but we can get the price point to be the same. This technology is way more advanced. What's the opportunity? Well, one opportunity is you can do loads more stuff, but the other is you can actually reduce the design challenge of making these things through things like abstraction. And that's the path we set up on. How can we use all this performance and power and all these sort of things, not just to do more, but actually to make development and integration of this technology more simple. I think the wording on there wasn't very good at the time, but I can't change it now. So, as I said, I met Chris and we sort of worked on this vision. And in the end of 2009, we launched something to do about prototyping. And we were ahead of our time. We were building internet-connected fish. So that was a fish that twittered, spoke Twitter. But interestingly, we set ourselves a challenge of building it the day before the show, which was always our philosophy. If you can build it, you have to build the demos the day before the show, otherwise your technology isn't good enough, because this is about prototyping. And in this case, the fish animated himself, and he read out things that posted on Twitter. But I think what I really got from this project was the plumber approach to doing this would have been, okay, well, we're going to have to do some sort of speech processing on this chip and all this, I can see how this is really complex, and this is probably a 3-month project, but we only had a day. So actually we fetched some stuff from Twitter, we then posted it to some other web service that converted that to audio. We posted it to some other web service that took out the syllables based on some scripts that Dan found, and pulled this all back down, and one of them drove the motors and one of them drove the audio. So by patching together all this stuff, some of it was in the cloud and some of it was mechanical and some of this thing, we actually pulled off this thing in a day. If we had 3 months, we wouldn't have built it like this, it would have been way more complicated. I think this was something that I found very useful. But anyway, the point was, we launched something. And this is an example of something that turned up a bit later. This is someone prototyping a product with stuff we're doing, which is excellent. But there's a reason I'm showing you this one. I assume no one can guess what this is, apart from the fact it's obviously wireless and internet connected, and that's why I'm showing you. Okay, so this is the newspaper article that goes with that. I don't know if you can read this very well, but I'll read it out. It says, the world's first device to help dairy farmers monitor their herd's dietary and health to improve milk yields of animals. This is pretty insane already. It's a real company. They build this sensor. It all sounds very nice. The well cow wirelessly monitors pH and temperature. Seems, very nice. It's even got an iPhone app that you can actually monitor Daisy. All seems quite normal so far. This is how to put it in the cow. It turns out this thing is about this big and weighs, I don't know, half a kilo, something like that. This is it's quite an interesting thing when we discovered this, and I think it kind of closed the loop on we didn't realise quite how close we were going to be with our pig feeding, but I think that exactly wrong end. But it summed up exactly what I think we were thinking about, which is you're doing what, and the other equivalent things that people seem to come from this perspective is they say, well, why didn't I think of that? It's so obvious in hindsight. Or the other classic one that I like the most is I had that idea 2 years ago, and of course by telling my friends in the pub, that turned into a company that worked out the supply chain and the business model and how to get this thing to market. So well done for coming up with the idea, but you didn't actually go and do anything about it. So I think this is the fundamental track that we've been on, and it was just quite interesting to see something quite so unexpected come back round. Okay, but that's enough looking backwards. the point I wanted to make was that this is sort of where a lot of our thinking has come from. So when you see what we've been doing, it's this sort of thinking that's driven a lot of where we've been going. But we don't have to invent this. So if you look at the web market and you think about what that looked like 15 years ago, or even the smartphone market and how that's come to exist, they're industries that didn't really exist 5-10 years ago. And you can actually go back and analyse what happened quite easily. So with web, there was lots of people, obviously it started off people writing web servers in C, and the web server was kind of part of the application, and that's how it started. And then things like Apache or other web servers came along, and suddenly that connectivity to a client is not part of the problem anymore. And then something like Rails came along and changed a lot of the way that people thought about web development. So, for example, one of the things I really found interesting about Rails was it introduced the concept of testing by default. It brought this framework that they learnt how this framework worked, and testing became an integral part of building websites and web infrastructure. It also became very accessible for people. So there's a huge interest in building websites like this, and fundamentally it started off as an interesting thing, and there was hackers doing this and whatever, but fundamentally it turned into actually how a lot of industrial websites are now built, with a lot higher productivity because of the right pivot point. So that's an interesting sort of technology map. That I think the smartphone one is, and people predicting Web 2 applications, you wouldn't have been able to predict the sort of things. If you think back, it was things like Encarta, Director being used for CD animation things. People, virtual shops on the internet and things like that. It's very different to actually where a lot of the internet technology took this world. And I think the smartphone industry is the one that we're really interested in drawing an analogy with, because up until the point that iOS and Android came out, there wasn't really much of an ecosystem around the mobile handsets themselves. That was a real step change in the way that people interacted with these phones, in the way they thought about actually what was possible. It became part of popular culture even about inventing apps. Pretty much in a pub every week, maybe in certain circles that we are in, not maybe all circles, but people were inventing what the next app was going to be. I think that was quite interesting. But the interesting thing that came out of that is it actually formed totally new industries. So if you think about the sort of companies that came out of this, there's companies supplying plugins for advertising for phone platforms, on the Android platform, or the tools to go and debug an Android application or something like that. It changed and it erupted a whole new industry based on certain platforms. I think we can learn a lot from that. So fundamentally, these are about platforms providing the right tools, technology, and ecosystems to enable a load of technology to coalesce in an area, and a load of people to build on that technology, to come to rely on it, to understand how they fit into it, and actually to drive those platforms as well in directions they want. So in the mobile space, if you were an accelerometer guy and there was an opportunity here, actually it's very obvious how you go and get into a mobile phone, because if accelerometers became part of the standard platform for using motion, things like that, that's actually how that new industry would be driven. So I think what we're assuming is almost inevitable, is that we're going to enter another era of embedded development. A lot of us in this room might be in box one, or at least started in box one. And I didn't choose these pictures, by the way. Dominic, our marketing guy, chose these pictures. So I don't know, is that a self-portrait? Yeah. So I think we've started to think that this is an inevitability, and this is, of course, doesn't mean that it's going to change the way everything is done, but it's going to introduce a new way that things are done. And it's not just it's not just an obvious step, but I think in some ways it's an essential step. So as John identified, there's these huge opportunities. There's going to be loads of industries that could take advantage of this technology, and they're not going to operate in the same way. So we see mbed as very much living in that third box about what does embedded platforms mean, and what will it change, and what can we learn from platforms that have gone before. And we can already start to see some of this in action. So here are some early platforms, and again, it's come very much from a sort of maker community, hackers and things like this. But it's already showing there's a demand for this type of technology. So a lot of, in some sense, things like the Arduino platform have been a huge success in popularising the understanding of microcontrollers. So a lot of people even it is synonymous with a microcontroller, and that's really amazing because that means so many people are now exposed to the concept of what a microcontroller is and what embedded intelligence could mean. And I think if you start to comprehend something, then you do start to think how to apply it, and then the next step is actually trying to apply it and looking at the ways to do that. And obviously things like the BeagleBoard project from TI, Raspberry Pi more based on Linux, and Raspberry Pi based on education. But again, incredibly successful, and people jumping on it because of this sort of platform approach. And perhaps the more interesting thing is this goes outside of the areas that perhaps they were originally defined for, because although they're not ideal for a new market, a professional developer or something like that, they're the best option, and that shows you that there's a demand for something. If this is getting used in ways that it wasn't intended, that's a huge insight into the demand that's latent in a market, and it actually ends up being the potential for something quite disruptive. So we can already see these sort of weak signals that this is looks like it's going to be an inevitability. But there's also other things like early companies. So I think Fitbit is something that people are very aware of, and this is common among a lot of people now. They understand this technology, it gives them insight into what's possible. Something like the Night Fuel Band, if you actually think back to when they generated it, this was for monitoring your run or something like that. But actually people end up wearing this all the time, even when they're not running. So suddenly Nike find themselves with all this information that they didn't even expect. And then they find themselves thinking, well, should we have this information? What can I learn by the fact that I know when someone's moving and when they're not, even they're just wearing it all the time. And that will spawn off lots of other ideas. It will spawn off lots of questions about this industry that we're going to have to solve. And something like Kickstarter, I think, is a great example of where people are now inspired that actually hardware manufacturing and hardware is accessible. And that's a great inspiration for a lot of people. Some other things, open source and open hardware have become very widely understood within the sort of markets we're in. And they're very scary to a lot of people. But fundamentally, they're an interesting way of consolidating a lot of effort among an industry, so that can be reused by a lot of people, which is a really valuable thing to do. Fundamentally, that's what ARM does it in a different way, but it consolidates a lot of engineering effort across an industry so lots of people can benefit and work a lot faster. And this quote here, I think, is fundamentally one of those. I've seen it quoted a few times now. But if you actually think what this means, it's not just saying that there's going to be new companies. If you start to model in your head what these companies look like, that changes the way that they're going to interact with the industry that is sort of inventing these technologies. So if you imagine yourself and you're setting up a company to do some IoT device, you haven't got any legacy, potentially. How's that going to impact how you work? You perhaps want to win a first customer, so you need to mitigate your risk as quickly as possible to prove that there's an opportunity for your product. How are you going to do that? Well, you might want to just get something out there and ship it and see what happens. Get it good enough, understand that you get into the market, or even the other one in such a growth market. This is a massively expanding market. Someone who is there first, even if it's with a ropey product, actually might have the opportunity to turn that into a really great company by getting there and understanding the market. Because by building a product, that's actually when you start to understand your customers. It's not about the technology, it's understanding your customers, how do you get to market, what's the problem, what are the issues, all these sort of things. So it's really interesting insight that comes from when you put yourself into the mindset of perhaps companies that don't exist yet and how they're going to want to operate. And so how many people have read this book out of interest? So New Hugo has. That's a surprisingly few. Okay, so Innovator's Dilemma, what did it say? Well, in some sense, you have to read the book really, otherwise I'm going to paraphrase it really badly. But in most cases, you're going to end up trying to destroy your own business or someone else is going to do it, because things generally have to disrupt. Because newer technologies come along that are good enough. So classic thing is someone's pushing up and to the right in terms of performance. Someone like ARM comes along and does something a lot cheaper, a lot easier to integrate into other things, and that's a very disruptive technology. And I think for us internally, doing something like Cortex-M was actually quite a hard thing to do. So we were doing various processors, moving our roadmap forward, getting more and more advanced application processors. And internally, in a bit of a skunk works, there's two guys that effectively started the Cortex-M project, and the architecture. One of them actually works in the mbed team now. But that was quite a scary thing for the company, because we're putting out something which is effectively disrupting ourselves. The reality is, that was a great thing to do, because it's opened up a huge new market for us that perhaps we wouldn't have otherwise been in. And interestingly, we did this to ourselves again. So Cortex-M3 was the first Cortex microcontroller we brought out based on the Cortex-M architecture. And we did M4. Actually, we also started doing some FPGA work just to understand what it would be like to run a Cortex-M architecture on FPGA. We did that as a different project, and people started wanting to put that into silicon. And we're like, well, that's not what it's for. Why would you want something like that? The Cortex-M3, we've got that. It's brilliant. And again, that was a very hard thing for the company to do, to disrupt itself with Cortex-M0. But having done it, it was really interesting. So yes, you disrupted some of the market that didn't actually want Cortex-M3. They wanted something really tiny like Cortex-M. But suddenly you opened it to a huge new market. So we're seeing huge amounts of interest in people who build sensors, or classically analog chips that just want something to replace a state machine in the corner of their chip, put more intelligence into the sensor. And by doing something like Cortex-M0, that actually opened up that market for us, and opened up the market for them as well. So now they can build sensors which have the microcontroller built in, a single chip solution, or a single package solution that perhaps wouldn't otherwise have been possible. So it's very hard to do it, but often when you do it, it's not nearly as bad as you thought it was going to be, and actually it opens up a whole load of opportunities. So I think that hopefully that sets the scene for why we think there's a disruptive opportunity in platforms, and it won't solve every problem, and it certainly won't replace a lot of the way things are done now. But we think it's an essential step to actually open this up to a huge new market. So that's fundamentally the sort of area we're on. The second thing I wanted to mention is we've been. So I'm starting to lay out, I think, what our long-term vision is going to be. But I also wanted to go back to the fact that we've been doing this for quite a long time in different guises. But the interesting thing for me is, over that time, we've effectively been planting all these little seeds. I don't think we knew it necessarily at the time. We were talking to lots of people. We were trying to understand their markets. We're changing our tactics all the time just to try and understand how this might evolve. And what we've started to see, and I think it was really at the start of this year, was things starting to come back. So it took a couple of years, but suddenly people we had talked to a couple of years ago were saying, "Oh yeah, we're doing this thing," starting to come back to us and talk about this. And it's like, "Oh, you know what you were talking about 2 years ago? This makes sense now. This fits what we're thinking about." And we've actually done this quite a lot. And this gives me a lot of confidence, not only that what the path we're on is the right one, because people are coming back to us, but actually also the fact that we're in a really good position to be able to do this. It's all very good to come up with an idea, but actually we've been working on this for quite a few years, planting all these seeds that are starting to sprout, and that's something that has put us in a very unique position. So for me that's very interesting. And the thing that fundamentally changed at the start of this year was we had been down here. Fundamentally, if you look back to what our original I guess philosophy was, we were looking at prototyping. We were looking at how does someone who's been used to 8-bit processors switch to these 32-bit processors. That's what we were thinking about. So we want to get the tools out of the way. We just want people to see what's possible. They'll see the value, and then they'll invest the time to develop. So we're very focused on effectively tools. And I guess over the last sort of 6 to 12 months, what we found is actually the people that we'd been ignoring, to be honest, because we didn't really know what to say to them, were coming to us more and more, trying to work with us. And it was people like mobile operators. They knew this market was going to be big, and they were trying to understand how do they engage with this market. It's a very hard thing to do, so they were coming and talking to us, and they were even asking us for things. We were saying, well, we don't do that, and suddenly you start to realise, well, perhaps we should be. Perhaps that's actually what that's what we are doing, because they're asking us for it. Can they can they use it in this way? Can they do that? You realise actually what you've unlocked potentially. The same with cloud service providers. So I've put Xively up as an example. We've got a couple of guys here from Xively. I think they realise that for their business to be successful, so they're a cloud service business providing, they can describe exactly how they would. I'm not their marketing guy, but sync for all this data coming from sensors. But they realised to be successful, they actually had to be getting the data coming from these sensors. And how are you going to do that? That your company relies on that to be successful. And then, so that's where we engaged with them and showed how we could potentially unlock it for them. And then we've been talking to contract manufacturers, partly because Chris is totally into how you actually manufacture things and help other people manufacturing stuff. So talking to these guys and realising actually the sorts of problems that people have, and how a platform can potentially improve the production process, not just the invention process, but actually how you then go and take that to market. There's lots of things that you can do that you don't need to reinvent, but it's very hidden from people at the moment. And as another example, so one of our first partner that really helped sort of drive this was NXP. We've been working with NXP since then. It's been one of our best decisions ever to partner up with them to get this far. But what was really interesting for us is when we were in a bar sometime, we just happened to be sitting at the same table with their NFC guys, and they found out what we were doing, and they almost got more excited than the microcontroller guys, because this actually unlocked their technology. They didn't care about the microcontroller. It's this annoyance. In fact, software is this annoyance that doesn't let them unlock their NFC or something like that. And they were spending so much time developing around, let's say, an NFC board, writing Visual Basic applications, talk to that board to show off what this NFC card could do. And you get this nice thing, it's a great demonstrator, but you can't do anything with it. And suddenly we had this thing which, they just wrote a library, and they had a dev kit. They had a dev kit that integrated with everyone else's dev kit who was using our platform. And for them that was incredibly valuable, and for us it was a real insight into some of the opportunity we had, I guess. So, as I said, this is the sort of thing that over the last year, and it's obvious in hindsight, really opened our eyes to the fact that what we were building could be a lot more than some microcontroller tools, which was fundamentally how we've been thinking about it to start with. And by turning around and looking away from the silicon guys, sorry, you open up and see what the opportunity was, because there was different people outside of that domain trying to solve this problem. So this is, I guess, where this is our mbed logo. This is where I would say this is where mbed is about to grow up. So based on that, and with John's support, we went to the board and basically laid out what we'd been doing and what we thought the opportunity with, and the timing was right, obviously, because of the need to invest in IoT and help all of our partners unlock this opportunity. So, as I say, mbed is kind of about to grow up. And there's a couple of things I wanted to show you on this slide. It might not be obvious. When we started mbed, we were very conscious to hide the fact it was actually anything to do with ARM. So most of our users at the start had no idea that this was anything to do with ARM. And that was by design for a lot of reasons, actually. One of them is, if it didn't work, I didn't want to take ARM's name. That was one of them. But the other one was, well, like I said, there was quite a few. The other one was we wanted to see if it worked. It worked. You know, we wanted a playground. We wanted to work in a different way. We treated it like a startup, actually, inside ARM, because that allowed us to try things that the legal team didn't find out for a year because we were hidden in a cupboard, which is now the legal cupboard. Actually, the cupboard the room we started in is now a cupboard for filing cabinets. But more than that, we wanted to see if it would work without the backing of ARM's name, because otherwise we might get adoption for the wrong reasons. We might get adoption because ARM is saying it's a good thing to do. So we've actually seen a lot of the success, quite ignorant to this, and it's actually only in the last couple of weeks, couple of months that we've started even looking at marketing and things like that. But this is really interesting for us. Because it proved a lot of this technology and allowed us to do a lot of things that we wouldn't have otherwise been able to do. But what we've realised is that it now is really the time to grow this thing up. So as I said, we went to the board and we presented the case for this, and we got the green lights to invest quite heavily in this project. So by the end of next year, this is going to be quite a big project within ARM, and we really want to use this as the opportunity today to lay out with you where we're going with this, because we think you can guide us very well on this path, and we think you will benefit if you come with us. So it's grown up as well, and the marketing guys decided it had to be capital as well. So come the start of next year, as we start to roll out this thing, the fact that this is an ARM project will become much more obvious. The fact that a lot of people within ARM are going to be getting engaged in this project will become a lot more obvious to people. So this is actually, ARM stepping up and saying, no, this is something we can really invest in. We're going to put the people and the investment behind it to make it happen. And this is why I think this is what triggered me to set up this meeting, because I think if we are going to do this, we want to do it right, and we'd like to do it in collaboration with all of you guys to do that. So this is the opportunity to help us do the right thing to help you all. So fundamentally, what is the mission? Well, ARM wants to help unlock IoT for all of our partners and generally for the world. If we can grow the pie in sort of Robin Saxby terms, that we will be part of that pie. So anything we can do to grow it is a big advantage for ARM. It's a big advantage for ARM's partners, but fundamentally we think it's obviously a good thing for the world if we can achieve some of the things that John was talking about earlier. So our goal is to help make the billions of these devices actually become a reality. Remembering back to the farmer type analogy. So the two things I wanted to dwell on. One, this is a crude definition of Internet of Things from our point of view. And the thing that's interesting to us is we are focused totally on helping people create devices. So we want to help people create devices that embed the intelligence that all our partners are developing. But that means actually we need to work way beyond that. So and we've started to see people come to us, which made it obvious that we need to work with the operators. We need to work with the people who provide the communication mechanisms to the internet. And in fact, we even need to work with the cloud services providers themselves to allow that technology to be put into the end devices to make those connections. And this is something that hasn't been on our radar up until about, let's say, 6 to 9 months ago. This is something where we're actually changing fundamentally the way we run the mbed project, the people we're hiring into the project, and the sort of the structure of the project in general to be able to scale to achieve this. So it's a pretty exciting time. And as I said, we're very focused on the things, and if you look in the things, well, what are these things? Well, it is the microcontrollers. It's where we start, but it's also talking to the sensor companies, understanding how to get their technology into this so that people building a cloud service can get access. It is the cloud service guys and it is the wireless communication. So later, I mean, the reason we dedicated a section to wireless is because this is actually a really complicated area that is conceptually incredibly simple. So, you know, fundamentally wireless, once you give them people access to the implementations and the mechanisms that are available, it's actually quite a simple thing to understand. It's still littered with problems, but fundamentally it's quite simple. But actually doing it is very complex, and it's not even considered a commodity at the moment, and we want to make sure we can get to the point, but this is just, it's not a feature anymore, this is just taken for granted. So I tried to summarise in one slide, I guess, where we're really going here. So we want to build a platform for Cortex-M, and a platform in the broadest sense of, you know, if you think back to the things I was talking about. Our main goal is to enable our partners and then developers to create devices on a massive scale, because that's what we need to unlock. We're going to base it on the open source philosophy, but from a commercially friendly point of view. And we'll talk about various reasons why we think this is a really interesting approach to take, and why, you know, some people won't accept it now, but we think in the long term this is the right thing to do. And we want to open it up to a vast new audience of professional developers. So if you think about the app ecosystem now and Web 2 sort of sites, those industries didn't exist, and the developers in those industries didn't have those industries to go and work in however many years ago. So we're taking the assumption that this is actually going to be whole new industries with whole new sets of skills coming in. There'll be professional developers, but they'll be totally using different sets of skills that perhaps have been seen before in the way that you pull these technologies together. And once you start thinking like that, you don't worry so much about perhaps what the industry looks like now, but how it might get to where we're thinking this would be in 10 years' time. And the second thing we really want to do is, as an industry, we want to consolidate the building blocks to build these devices. So in the embedded space, a lot of what I think the people in other respects, and Dan is a good, my web team is a really good example. He's not an embedded developer, and he's often saying, why is this a feature? Why is this even difficult? I think that's what we need to learn from other industries, that a lot of this technology is inevitably going to get commoditized. And actually we want to drive that commoditization of this technology to make it available to lots of people, because actually the value of doing that to the industry is worth way more than trying to capture the value of those building blocks. Not for everyone, not for all aspects of the industry, but for the segment that we care about, we think driving that and getting the industry to consolidate this efforts will pay off many times over. So the sort of things we're caring about are microcontrollers, the radios, the sensors, and the software stacks. In terms of wireless connectivity, there's obviously a huge array of wireless connectivity options. But to start with, we're betting on 5, if you include wired communication like Ethernet. But fundamentally, we're looking at Bluetooth, and particularly Bluetooth Smart. We think that's going to be a massive area that people understand it's going to be big. I don't think they quite understand how big it's going to be. We might be wrong, but I suspect this is going to be a massive market. 802.15.4 and 6-low-PAN. So as you probably know, ARM acquired Sensinode recently, who pioneered a lot of this technology and have brought a lot of expertise into ARM. And we want to really help all of our partners take advantage of these technologies. So we'll be talking about that as well. Wi-Fi and fundamentally cellular. Cellular has some really interesting opportunities in terms of business model of just connectivity not even being a feature in the end user's mind. It's just magic. Somehow it's connected to the internet. And I think an example would be something like the Kindle. If I asked, I don't know how many people got a Kindle actually? How many people, maybe it's different in America, but how many people know who the service contract is with? Like one guy, right? So you don't think about, maybe it's because you don't have the 3G one, right? Sorry. But fundamentally, something like the Kindle changed the business model. Up until now, cellular was thought of something where you had a relationship with the operator on a monthly contract or something like that, or pay as you go. And something like Kindle actually totally changed that business model. The business model is you buying a book, and that subsidising some of the operator costs, and that's huge. So we'll talk about cellular as well. And we want to consolidate some of the embedded agents as well, so the things that actually talk out to these cloud services. Because if they're available and they're not a feature anymore, then just connecting and pushing data out of these things becomes possible. And the main thing to do, the main reason we're very interested in standards in this place is to make this industry scale. We want to disaggregate all these parts of the industry. At the moment, everything is very vertical, and it will continue to be very vertical for a while in certain areas. But to really get this to scale, you need to be able to disaggregate all these different parts of the industry so someone can make a generic sensor, or they can just make a cloud service which is resold, rebadged, and repackaged to someone else who is the maintainer. You have to have all these chains of like you do in other industries. So that's why for us standards are very important, and anything we can do to proliferate and make available these standards we think is great for growing the industry. Okay, so and tools and ecosystem. So tools is obviously one of the things we're talking about. An ecosystem is kind of what I want to make sure that we make the connections today. So I just wanted to give you a bit of an insight into, as I said, we've been planting some seeds. So I wanted to give you a bit of an insight into some of the ecosystem from our point of view. So NXP was is a brilliant partner for us. So when we were starting this project and we had a vision, we were trying to find someone this resonated with, and it resonated with NXP, and together we bootstrapped this project. So that this was really excellent for us as a way to develop the project, and that was actually enough for us for a while to develop this. But earlier this year, it was excellent to announce that Freescale joined the mbed project, and we'll be doing a lot more with Freescale over the next year. So this is pretty exciting. So this was the next step. But I'm really pleased to announce a few more things today, which I think hopefully you'll see that planting these seeds is starting to pay off. So I'm really very excited that we're now going to be working with Nordic as well on Bluetooth Smart. So Nordic are producing Bluetooth Smart chips with Cortex M0 embedded, and we've started a project with them to enable the mbed platform to target these chips, and they're maybe $2 in volume or something like that. Not even, right? Yeah. So they're really cheap devices that, and we'll go on to Bluetooth Smart because personally I'm very excited about this technology. But this is really interesting, I think, to open up a new market, and this is something I'm particularly excited about. Unfortunately, because of lawyers, I was hoping to announce another big partner as well, another big silicon partner. But apparently contracts take some time to work at. There's lawyers fighting or something like that. But this is really exciting for us because this is, as I said, mbed's about to grow up. So in terms of from our microcontroller partners, with NXP, with Freescale, with Nordic, and we'll hopefully be able to announce in a few weeks another major silicon partner. This is really great for us. This is about to get real as far as we're concerned. Not that it wasn't real before, it's about to get more real. But I also wanted to talk about a few other things. So as I said, we started working with other companies. So u-blox provide cellular modems and are doing very interesting take, because they're not doing the whole stack of services. They're looking for very low cost modules, and we've been working with u-blox to enable those modems, so these cellular opportunities under the platform. And of course they could leverage, in this case I think they've built the first platform with an NXP part, because they could just leverage all that ecosystem that mbed bought. And this is the sort of thing we think now it's on our radar, and we can support these companies, and we're hiring people to support these companies. This is actually something we're in a really great opportunity to scale, so all the pieces of the puzzle can benefit from everyone else being part of this project. So we'll introduce this a bit later, but another really exciting thing, because this is opening up cellular in a way perhaps that hasn't been done before. I'm not going to dwell on this, but we've been working with mobile operators as well in conjunction with that. I'm not going to go into this too much more, although Karthik later will talk about this. But this is really interesting and opened up our eyes again. So understanding how to support these people, how we can benefit them is pretty cool. I want to put SensorNode up there. So we've got Zach with us, who'll be talking later. He's one of the founders of SensorNode and pioneered a lot of the wireless sensor network technology. Are you into standards a bit? A little bit, right? So slightly religious about standards, which is awesome, because this is really how ARM believes if we can make these standards successful, it will really allow the industry to scale. And internally, we brought the mbed team and the SensorNode team together, which is really exciting for us as well. So hopefully they can learn a lot from us, but also we're going to learn a hell of a lot from them as well, which is really exciting. So there's a lot of opportunities around wireless sensor nodes and enabling actually what is not that easily accessible at the moment. But I think if you look at this in a year's time, I think all the sort of technology that SensorNode and companies like it have been pioneering is going to be way more prevalent than perhaps than is now, and we want to help do that. I thought I'd mention Zively as they opened up our eyes to actually why the cloud operators even cared working with us. This is not something that we'd been thinking about, but when they came to us and said, actually, this is a problem for us. How can you help us? We're like, oh, crap, yeah, we can really help you, can't we? And it is another ingredient we see coming into this platform, coming into this ecosystem that fundamentally we want to build. So we're very grateful that Zively approached us and hopefully start a good relationship with them, but also with other competing cloud service operators. And another thing I'm pretty excited to mention is, so we're working with, we're working with Oracle in conjunction with Freescale. So Oracle have been looking about how they enable Java ME on the Cortex-M microcontrollers. And this is actually quite a hard thing to do because, well, there's two reasons. One, historically, the performance and the processing power and the memory hasn't been available in these sort of single-chip microcontrollers. But actually, if you look over the next year, the next 2 years, this is going to become, this is inevitable. This is actually, that problem will go away. But secondly, Java is often run on platforms like Linux that have available to them all these sorts of services and components. When you look at an IoT device, you're going to have an accelerometer, a GPS, a this, that, the other, wired up to a microcontroller. And actually, mbed can be used as the how to provide all these services to the Java environment. And that means the guy right at the end who's perhaps adding the identity or the behavior to a device might be using Java, but he's leveraging all this investment that we've put into this platform to unlock these bits of technology. And that's really exciting to understand how that's going to play out. So it's pretty exciting for us. So yeah, so this is the slide I wanted to end on. I think with mbed's a very tangible project. We're doing very technical things. This is about code, it's about tools. But at the same time, this is about trying to understand this ecosystem that there's an opportunity to build. And we want to understand how we can help these different industries and how we can bring them together so not everyone has to talk to everyone. We can all consolidate, hopefully under this project, to enable everyone to be very successful in this market. So that's what I hope that was interesting for now. And there's one other thing I want to do before we break. It'll be about 15 minutes, or less if I can be quicker. This hopefully. Does anyone have any questions at this point? I know we're quite early in the day, but is anyone bold enough to want to ask a question?
Yeah. Are we going to get this presentation?
Good question. So you won't get it at the end of today, but our plan is to, after we've understood what the questions were from people, spend a week or two putting together some information, understanding if there's anything that we shouldn't share or whatever, and then make something available, definitely. So and that'll be all the presentations throughout the day. We'll make everything available, but you won't get it at the end of the day because we want to actually spend some time understanding if we can fill in any information that we missed, because we'll probably get half of today wrong, because we haven't spent enough time with you yet.
So, is there any way today you're talking about security? Because it's one of the big areas we're spending a lot of time looking at with IoTs.
Yeah, so we'll touch on it in a few areas, and I think so the other thing is we do have a set of slides, but actually we have a load of clever people in the room I'm including everyone in there, who can talk about anything. So I'm very open to those sort of things. So yeah, I mean, I think Zach can probably talk a lot about security. So if that's interesting, it's not a main topic, but I think if you think about what we're trying to do, we would like to make the best practice security standardly available. That would be one of our goals. So understanding what you're thinking about, what your requirements might be is perfect. We won't go into security standards that much today, although Zach might be able to expand on some of that at the time. But fundamentally, yeah, these are the sort of things we want to do. So feel free to steer the agenda.
Are we going to talk about ad-hoc networks or Wi-Fi or something, or 802.11?
Yeah. So we'll cover that. Yeah. And as I said, the people that are presenting are not people that are necessarily totally versed in PowerPoint. They're totally versed in their technology. Right. So feel free to ask.
With respect to security, what I've seen is it's not so much the algorithms per se, whether it's AES or block site, it's implementation, key management, infrastructure, and that's still pretty much ad hoc, especially embedded. And so what I've often seen is you get an engineer who's bright, knows that you need to use a tool, gets it, but then he's left to his own to figure out how to architect around it. And that's usually where the weaknesses are. So what I would see sort of this aspect of it is something that needs to be commoditized.
So it's not the core technology itself, but it's actually how you integrate it with.
Yes.
Okay.
Yes. So how do you manage passwords, for example? How do you access these things to change them? So if I make an AES cipher on a block, that's bulletproof. I get a good password.
Okay.
What's a good password? How do I generate one?
Right.
And that's where you leave a real heavy-duty expertise to someone who doesn't have it to make that decision.
Right. Yeah.
And then they build something that's weak.
I'll talk about that in a moment.
Yeah. I mean, in the topic, we haven't explicitly got a security section, but is this something that's on a lot of people's minds? Yeah. Okay. So maybe we can use part of the open panel session to open the floor to those sort of questions. And we've got a few experts from our side, but hopefully a few of you are experts on this area as well. I think that'd be a great topic of conversation, actually. But yeah, I mean, there's lots of us that have been thinking about it, but to get a sort of a whole view would be superb. And I guess under this project, we're also contemplating the idea of almost working groups. We haven't quite decided if that's the right format or whatever, but certainly Bluetooth for me is something that's interesting. There's a lot of different type of parties that might have an interest in understanding how to push it forward. Maybe there's something around security as well. But don't know the quite format, but we can discuss that over the day. Yeah, that'd be great. Any other sort of burning questions at the moment?